Welcome back. In front of us, we have a set problem, and it reads, the universal set U is a set of all integers from 1 to 14. P, Q, and R are subsets of U and are defined as follows. Set P is equal to 1, 2, 3, 4, 9, 10, 11, and 12. Set Q is equal to 3, 4, 7, 8, 11, 12, 13, and 14. And set R is equal to 3, 4, 5, 6, 9, 10, 13, and 14. Find question 1, P union Q. Question 2, Q intersection R. Question 3, P intersection R all complement. Question 4, P intersection Q union P intersection R. Question 5, R intersection P complement. Question 6, P union Q intersection P union R. Question 7, P complement intersection Q union R. Question 8, P intersection Q intersection R. So it is possible that just by reading the question, you could be intimidated. But when you take it step by step, you will be able to solve this problem. It is a set that has 3 sets in it. Okay, we have set P, set Q, and set R. So let's go on and try to answer the problem. Solution. Set P is given as 1, 2, 3, 4, 9, 10, 11, and 12. Set Q is given as 3, 4, 7, 8, 11, 12, 13, and 14. And set R is given as 3, 4, 5, 6, 9, 10, 13, and 14. So one thing you have to understand first is by looking at the sets that are given to you, you should be able to know how the sets are going to look like when you draw a Venn diagram. The first question that you have to ask yourself is, are there numbers that are common in all the sets? And if you look at it, we have 3 and 4, 3 and 4, 3 and 4 in all the sets. So which means these 3 sets do have common intersection. Okay? So the way you try to draw it will be, you're going to have 3 sets that are going to have a common intersection, which is here. All right? So if this is set P, let's say this is set Q, let's say this is set R, 3 and 4 will be here, okay? Because this is where all the 3 sets overlap. So for the point of overlap between P and Q only, is here. Okay, that will be members that are found in both P and Q only. Okay, and if you look at that, we have 11 and 12. Okay, so 11 and 12, the position is going to be here, not here, because we do not have 11 and 12 in set R, as you can see. So remember, this point is the common point for all of them. So whatever value you're going to write here, or whatever number you're going to write here, must be a number that is present in all the sets. And this region that I am shading in yellow is the members that are common in set R and Q only. Just set R and Q. Okay, so if you go to set R and Q, or Q and R, it doesn't matter, you will have numbers that are just present in both of them. And what are those numbers? If you look at it, they are 13 and 14. Okay, 13 and 14. So which means this is where you're going to write 13 and 14. And the region that I am going to shade blue is the region where you have common members between P and R. Okay, the common members between P and R, what do we have as common members between P and R? If you check, you have 9 and 10. 9 and 10. Okay, 9 and 10. Right, so this is where you're going to write that. So the areas that are left, that is, for this area, it is going to be numbers that are only in P and not in other sets. Here will be numbers that are only in Q and not in other sets. And here will be numbers that are only in R and not in other sets. So when you have this understanding, you can be able to draw your Venn diagram. Okay? So let me try to go through the intersections once again. For set P and Q, we've said that set P is 1, 2, 3, 4, 9, 10, 11, and 12. And for set Q, we said that it is 3, 4, 7, 8, 11, 12, 13, and 14. So what will be P intersection Q? That is members that are found in both set P and Q. Let us try to identify them. We have 3, we have 4, we have 11, and we have 12. So let's write them down. 3, 4, 11, and 12. We are done for set P and Q. So let's go for set P and R. So set P again is 1, 2, 3, 4, 9, 10, 11, and 12. And what about set R? Set R is given as 3, 4, 5, 6, 9, 10, 13, and 14. set R is 3, 4, 5, 6, 9, 10, 13, and 14. So what is P intersection R? Let's try to identify them. P intersection R, we have 3, we have 4, we have 9, and we have 10. So they are 3, 4, 9, and 10. And finally, for set Q and R. So what is set Q? Set Q is 3, 4, 7, 8, 11, 12, 13, and 14. And what is set R is 3, 4, 5, 6, 9, 10, 13, and 14. So Q intersection R can be identified as we have 3, we have 4, and what? We have 13 and 14. So Q intersection R is 3, 4, 13, and 14. With this information, we can be able to draw our Venn diagram. So if you look at it, we have 3 and 4 for all the associations. Okay? 3 and 4. So which means 3 and 4 will be the numbers that are in all the 3 sets. So how do we indicate that on the Venn diagram? Let's try to have our Venn diagram now. So this is the Venn diagram. All right. On the Venn diagram, we have the universal. Never forget to indicate that. So let's call this set P. Let's call this set Q. And let's call this set R. Numbers that are common in all the 3 sets, we said that are 3 and 4. So we'll have 3 and 4. So what do we do next? Let's go and identify numbers that we have that are in both P and Q. For P and Q, apart from the 3 and 4, we have 11 and 12, right? So which means that is what we're going to write here. So we're going to have 11 and 12. Okay? So what about numbers that are both in Q and R? For Q and R, apart from the 3 and 4, we have 13 and 14. So which means we're going to write 13 and 14 here. Then what do? We need to fill in the space here. Numbers that are found in P and R only. P and R only. What are the numbers that we have for P and R only? P and R only. Apart from the 3 and 4, we're going to have 9 and 10. So that is 9 and 10. Okay? So what do next? We try to fill in the numbers that are found in the individual cells only. So for P, if you go back to the sets in P, whatever is remaining, that is what we need to write now. So is 1 and 2, right? 1 and 2. For set Q, what is remaining? For set Q, 7 and 8 are remaining. And for set R, what do we have remaining? Is 5 and 6. So what do we do next? We try to confirm whether we have everything right. So just by considering here the members of Q, we have 3, 4, 7, 8, 11, 12, 13, 14. So this entire circle is for set Q. For set R, let's look at the members. We have 3 and 4. We have 5 and 6. We have 9 and 10. We have 13 and 14. So all the members for set R are here. Okay, so this circle is for set R. And finally, let's confirm for the members of set P. For set P, we have, if you look at it here, we have 1, 2, 3, 4, 9, 10, 11, and 12. So this is set P. We have 1, 2, 3, 4, 9, 10, 11, and 12. So as you can see, this is the correct Venn diagram. So without wasting time further, let's go straight and answer the questions. Question 1 is P union Q. Question 1 is P union Q. That is, if you unite set P and Q, what are the members? So let me just try to extract the diagram for you and try to show you that. For set P and Q will be the members that you have here. That is P union Q. Okay, so what do we have if we unite P and Q? We're going to have 1, 2, 3, 4, 7, 8, 9, 10, 11, 12, 13, and 14. Okay, 1, 2, 3, 4, 5 and 6 are outside. So you have 7, 8, 9, 10, 11, 12, 13, and 14. That is the correct answer for P union Q. Okay, so that is it. Moving to question 2 is Q intersection R. Question 2 is Q intersection R. So where is Q intersection R? From the diagram here, Q and R have intersected at 2 places, here and here. Okay, so Q intersection R is this region. So it's 3, 4, 13, and 14. All right, 3, 4, 13, and 14. Do not make the mistake of just writing 3 and 4. or omitting 3 and 4. Remember, these 3 and 4 are the numbers that are in all the 3 sets, but they still form part of Q and they still form part of R. So Q intersection R is 3, 4, 13, and 14. Moving on to the third question. Is P intersection R all complement? P intersection R all complement. What that means is identify P intersection R. If you exclude that, whatever you have in the universal set, you need to write it down. So if I should identify P intersection R, where is it? Let me try to extract this diagram again. What is P intersection R? Where have P and R intersected? P and R have intersected here. This is their intersection. So if you exclude this, whatever you have, that is what will be the complement. Okay? So P intersection R all complement means that we are going to write all the numbers except 3, 4, 9, and 10. So let's write that down. That is 1, 2, 5, 6, 7, 8, 11, 12, 13, and 14. Right? That is P intersection R all complement. Complement means you exclude that. So identify P intersection R first. When you exclude those members, whatever you have as remaining, that will be P intersection R all complement. Okay? And the members are 1, 2, 5, 6, 7, 8, 11, 12, 13, and 14. We are now going to move on to answer question 4. And what is question 4? Question 4 is P intersection Q union P intersection R. P intersection Q union P intersection R. Okay? Don't be intimidated with this instruction. First, what it means, try to find P intersection Q, then find P intersection R, and since you have union in between them, means that you join them. Now, what is P intersection Q? Let's try to identify that from the diagram. If I should extract the diagram again, what is P intersection Q? Let's identify that P and Q. The P intersection Q is going to be this, 3, 4, 11, and 12, right? 3, 4, 11, and 12. So what is P intersection R? P intersection R, that is where P and R have intersected, will be this. It's 3, 4, 9, and 10. So we are done. Union means you unite. So therefore, P intersection Q union P intersection R will be, what are the members? 3, 4, 9, 10, 11, and 12. All right? So that is the answer. Moving on to the fifth question. What is the fifth question? The fifth question is R intersection P complement. R intersection P complement. R intersection P complement. What that means is, first let's try to find the members of R. Set R have members 3, 4, 5, 6, 9, 10, 13, and 14. 3, 4, 5, 6, 9, 10, 13, and 14. This is set R. So let's try to find P complement. P complement means members that are not found in P. Okay, so that is, if you exclude P, what do you have? P complement. Again, let's try to see the diagram for that. If I should try to exclude set P, members of set P, that will be this. Okay? Whatever is remaining then, that is going to be P complement. So what do we have as P complement? For P complement, we're going to have 5, 6, 7, 8, 13, and 14. Okay, so what does R intersection P complement means? Intersection means members that are found in both of them. So let's try to identify them. So you have 5, you have 6, we have 13, and we have 14. So therefore, R intersection P complement is 5, 6, 13, and 14. Let's move on to answer the sixth question. The sixth question is P union Q intersection P union R. P union Q intersection P union R. P union Q intersection P union R. This is what we want to identify. So the first thing is, let's find P union Q, then we find P union R, and then we find the common members. Okay, so let's identify them. P union Q, what are the members? If we go back to the set again, this is the set. Okay, so what is P union Q? For P union Q, you have to unite set P and set Q. That is it. So that is going to be 1, 2, 3, 4, 7, 8, 9, 10, 11, 12, 13, and 14. Right? That is P union Q. So what is P union R? Let's try to identify that. P and R. P union R is this. Okay? So P union R is 1, 2, 3, 4, 5, 6, 9, 10, 11, 12, 13, and 14. So that is P union R. But the question is asking us to find the intersection, that is the common members between the two sets. So what are the common members? We have 1, we have 2, we have 3, we have 4, we have 9, we have 10, we have 11, we have 12, we have 13, and we have 14. So P union Q intersection P union R will give you 1, 2, 3, 4, 9, 10, 11, 12, 13, and 14. All right? Okay. So let's move on to question 7. What is question 7? Question 7 is P complement intersection Q union R. P complement intersection Q union R. That is it. Meaning that we first have to find P complement, then find Q union R, and then we identify the common members. Okay? So what is P complement? We already have the answers for that previously. That is 5, 6, 7, 8, 13, and 14. 5, 6, 7, 8, 13, and 14. So what is Q union R? Let me try to obtain that from the set. Okay, this is the set. So we want to find Q union R. Q union R, that is unite set R and Q. Okay, so this is Q union R. What are the members that we have for Q union R? We have 3, we have 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So intersection means finding common members. What are the common members? We have 5, we have 6, we have 7, we have 8, we have 13, and we have 14. To answer the question, P complement intersection Q union R is the same as just the members of P complement, right? That is 5, 6, 7, 8, 13, and 14. And finally, question 8 is asking us to find P intersection Q intersection R. What that simply means is where P, Q, and R have intersected. That is here. And it's simple. We've said that that is 3 and 4, right? From the diagram. That is here. 3 and 4. P intersection Q intersection R, we only have 3 and 4. And that answers the question. Thank you very much for watching this video. If it is very useful to you, please like the video, share it to your friends, and do not forget to subscribe to our channel. It means a lot to us. See you soon in our next video on set theory.